In the last lesson, we learned that SOHCAHTOA isn't the only way that we can use trig ratios in order to solve for missing pieces of a right triangle. So in the last lesson, we learned about law of sines. And law of sines can be used anytime you're given two angles and a side, whether it's an included side or not. So we can use it in the case of ASA or AAS. And we also learned that we can use it in a case where we have two sides and an angle, but that angle cannot be included. And remember, this case, the SSA case, presented quite a few problems for us because it's the ambiguous case. No, so what we learn now is if we're not given any of these options and we're given these two instead, we have to use what's called law of cosines. Now, law of cosines can be used anytime you're given three sides or you're given two sides and an included angle. So the reason why we have to use law of cosines instead of law of sines is because in order to use law of sines, which looks like this, we have to have one of these ratios fully complete. So I either need to know both angle A and side A, B and B, C and C. And what happens is in the case of side angle side or in side side side, you don't have both things of the same letter. So law of sines doesn't work because you cannot complete the proportion in order to solve it for one unknown. So we have to present a new process, which is called law of cosines. Law of cosines has three variations. They're all right here. If you notice, they all look very similar, and the reason why is because they're all based off of the exact same thing. So how do you decide which one you're supposed to use? It all depends on either which angle are you trying to find or which angle were you given to start the problem. So if I'm trying to find angle C, then I would use the third one because it has angle C in it. If I was given angle A, then I would use the first one because it has angle A in it. So again, the formula, whichever one you use, is totally based off of one of two things. Either which angle am I given to start the problem, or which angle am I trying to find using law of cosines. So in the first problem, this is a case of side angle side because I have two sides and and an included angle. And when I try to decide which formula I'm going to use the second one because I'm given angle B. So all we're going to do is plug everything in. Keep in mind, whenever you're using law of sines or cosines, the little letters represent side lengths and the capital letters represent angle measures. So in this, we would have B squared equals A squared plus C squared, so 11 squared plus 14 squared, minus 2 times 11 times 14, multiplied by the cosine of B, which is 34 degrees. So plugging everything in correctly, we literally just have to plug everything in the calculator. So I'm going to pull up my Inspire and do that. And what we get is 61.7 about. Now keep in mind that this number is not the side length for B. That's actually B squared, because if you go back to your formula, it says B squared equals. So if I want to figure out what B is, I then have to take the square root of that value. So we're going to take the square root of that value, and we end up with a side length of 7.9. And one decimal place is fine for all of this. So now that I know that this is 7.9, whoops. The nice thing about finding letter B first is that now I know both angle B and side B. Now, since I know both of those, that means that I can go back to using the easy process, which is law of sines. Now, if you want to, could you continue using law of cosines? Absolutely, but it's probably easier just to use law of sines. So from that point on, what do I do next? Well, good rule of thumb to follow is you want to find the largest angle first. So if you're trying to find angle C and angle A, you have to ask yourself which one would be larger. And in this case, it would be angle C because side C is larger than side A. That's triangle inequality that you learned from geometry. So if I'm going to find angle C, I'm going to use angles B and side B in order to use law of sines. So sine of 34 over 7.9. I'm trying to find angle C, and little c is 14. So some things to keep in mind here. When we're solving, we're going to cross multiply and divide. Now when you cross multiply and divide, you're going to get a nasty decimal. So 14 sine of 34. We're going to divide that by 7.9. Now obviously the angle measure is not going to be 0.990975. In order to find an angle measure, remember, we're always going to do inverses. So if we're trying to find an angle for the problem, we're going to do inverse. Now, rather than rounding the decimal for myself, I'm just going to do second answer so that the calculator uses the entire decimal and it types it for me. So if I push enter, we end up with a degree measure of 82.3 degrees, which makes a whole lot more sense than that large decimal. Finding the last missing piece is then very easy. Now that I know what angles B and C are, to find A, all I have to do is subtract from 180. So subtracting both of those from 180 gives me 63.7 degrees. So we've solved the triangle because we found the three things that were missing. So there are actually, like I said, two cases of law of cosines. Side angle side is the easier of the two cases. So we are going to go straight to number 2 here so that we can see what the harder case looks like. So in order to do this first, we would want to draw a triangle. So I'm going to do that. And again, we're doing number 2 here, not number 1. And in this particular case, all we're given is the 3 side lengths. So in order to start law of cosines, since I'm not given an angle to begin with, I need to figure out which angle it is that I should find first. So remember, like I said, rule of thumb, always go largest to smallest. So it's going to be best to find angle B first because side B is the longest side. Since I'm going to find angle B first, I'm going to use the formula that starts off as B squared equals. Because if I need to find angle B, I would want the formula that has angle B as a part of it. So I'm going to start plugging in everything. 16 squared, we've got 14 squared and 9 squared, 214 times 9, and then cosine of B. Now this one isn't as easy as the last one, because this one is not already in the form variable equals. So we actually have to rearrange this and solve it for B. Now we're going to do this step by step because I don't want you to make a silly algebra mistake. So this is going to seem really stupid, but I want you to do it step by step with me so that you can see where these numbers are coming from. First thing, we're going to simplify. 16 squared is 256. 14 squared is 196. 9 squared is 81. 2 times 14 times 9 is 252. Now the biggest mistake that students usually make with this is when they combine in the next step, they want to combine all 3 of these numbers. You can't because the 252 is attached to the cosine using multiplication. So you can't combine the 252 with the 196 and the 81. So please be careful when you're doing that. The only ones you can put together are these 2. So together, that 196 and that 81 is a total of 277. So I'm going to subtract that from both sides. So on the left-hand side, I have a total of negative 21. The right-hand side is negative 252 cosine of B. So what I would want to do here now is I'm not going to add the 252 to both sides. We are going to divide both sides by 252. And doing that is going to give me a fraction of 1/12. So just like previously with law of sines, things to keep in mind whenever you're trying to find an angle, at some point you're going to have to do an inverse trig function in order to find that angle. So in this case, since it's cosine b equals 1/12, we're going to do cosine inverse of 1/12. So by doing that, we get an angle measure of 85.2 degrees. Now, when I go back up to the top of my picture, we've just found this angle. So again, just like in the previous problem, by finding that first initial piece, that now gives me a set of both the angle and side of the same letter, so I can go back to using the easier process, which is law of sines. So that's exactly what I'm going to do. Now you have to ask yourself which angle would be the one to find next. The answer to that would be A, because it's the largest or the next largest. So when we set up law of sines, we're going to do B over B because it's the only set we know fully. And then we're going to find angle A first because it is the next largest angle in the triangle. So finding A, we're going to cross multiply first and then divide. Now remember, when we do this, cross multiply and divide, it's not going to give me the angle right away. I'm going to have to do the inverse in order to find what A is. So let's first do 14 sine of 85.2. Then we're dividing by 16. And that decimal obviously is not going to be the correct answer. So we would need to do sine inverse of that. Oh, you know what? I made a mistake. We need to hold on a second. I see my mistake. If we scroll up, we're doing law of cosines, and I did sine inverse instead of cosine inverse. So we need to fix that. So let's back up a second. When we did this step right here, let me highlight it. When we did this step right here, I did sine inverse instead of cosine inverse. So 85.2 is not correct. Let me fix that. So we're going to go up here. Okay, so let's do that real quick. I apologize. So we're going to do cosine inverse of 1/12. It comes out 85.2 still, which is odd. Okay, so I lied. I just confused myself. Sorry, the 85.2 is actually right because I did it in a calculator that's in my hand, not on the Inspire on the board. 85.2 is correct. Okay, so anyways, so we're going to cross multiply. So 14 and sine of 85.2. We're going to divide by 16, and we're going to do sine inverse of that value. So back to where we were. Forget everything I just said for about the last minute and a half. So what we end up with for angle A is an angle of 60.7. Okay, the last thing we would need to find is angle C, and angle C can be found by just subtracting the two that I found from 180. So doing that subtraction gives me a total of 34.1 degrees. So we found the three missing angles in the triangle. So law of cosines has two different formats, side angle side and side side side. So what I've done here is given you one example of each one. On the back of this is just another way to find the area of a triangle given all three of its sides. So what you were probably told in geometry last year is that you can't use all three sides of a triangle to find its area. It's not exactly true. There's this formula called Heron's formula, and this is what the formula is right here. If we take and find all of these values, then we can just plug them into this formula and it finds the area of the triangle. So the first thing is there's an S in the formula. That S is called the semi-perimeter. So it's the perimeter just divided by 2. And then all you're going to do is S times S minus A, S minus B, S minus C. A, B, and C are the lengths of the triangle. And then you're going to take the square root of whatever you get. So the first thing you would do in a problem like this is find what the semi-perimeter is. So 5, 8, and 11 all divided by 2. 5 and 8 is 13, 11 more is 24. Divide by 2, you get 12. And then we're just going to plug it in the formula. So the area is that 12 multiplied by 12 minus 5, 12 minus 8, and 12 minus 11. So plugging that in the calculator, get 12 times 7 times 4 times 1, and we get 18.3 as my area. Now, obviously, if there were units in the problem, you would include units in the answer. This one doesn't have units, so we just use a unit squared. Last problem, if I add up all of the sides and divide by 2, 12 and 15 is 27. Add 23 more, you get 50, and divide by 2, you get 25. So plugging all of that into the formula, it's S, and then S minus A, and then S minus B, and then S minus C. Oops. So if we plug all that in the calculator, square root of 25 multiplied by 10 multiplied by 2 multiplied by 13, and we end up with an area of 80.6. And again, if there were units in the problem, you would include units in the answer. I'm using u squared since there are no units expressed in the problem. I apologize for any confusion on the side problem. If there's any questions about any of that stuff or anything that I had said that I was mistakenly said that I thought I made a mistake on but I hadn't, just ask in class and I will talk about it. If you have any other questions, just make note of them and you can ask in class.